21:50 on a bitter February evening 1969. Platform 3 at York Station. An 8-coach mail train bound for Aberystwyth sits under dim fluorescent lights, steam rising from the brake pipes into freezing air. But something is wrong tonight. The locomotive at the front is not what anyone expected. Number 5150, a diesel, stands coupled to a service that has no business being diesel-hauled. It is running as a local between Leeds and Huddersfield because somewhere east of the Pennines the entire electric railway has collapsed. Not from age, not from neglect, from ice. This is the story of how Britain's most advanced electric railway was brought to its knees by a winter storm, and how diesel locomotives, the machines the Woodhead route was supposed to make obsolete, became its only lifeline. The Woodhead route between Manchester and Sheffield was no ordinary railway. It carried one of the most important trans-Pennine services in the country, threading through 3 miles of tunnel beneath the highest point of the line at over 1,000 feet above sea level. The original tunnel, bored in the 1840s at enormous human cost, had been joined by a new tunnel completed in 1954, built specifically to accommodate the overhead line equipment for the new electrification. Since that year, the route had been fully electrified at 1,500 volts direct current, using overhead catenary wires strung on steel masts across some of the most exposed terrain in England. 58 Class 76 locomotives and 7 Class 77 locomotives were built to work the route. Powerful machines designed specifically for the heavy gradients and demanding traffic patterns of the trans-Pennine corridor. The electrification had been a triumph. The Class 76 and Class 77 electric locomotives replaced steam on the heavy coal and passenger trains that climbed the grueling gradients either side of the Pennine summit. Journey times dropped. Reliability improved. The Woodhead route became a showcase for what modern traction could achieve. But the engineers who designed the overhead line equipment knew something that the publicity departments preferred not to mention. Those wires, strung across open moorland at altitude, were exposed to weather conditions that no other electrified railway in Britain had to face. The catenary ran through terrain where horizontal sleet could coat every surface in minutes, where temperatures dropped well below freezing for days at a time, where wind speeds regularly exceeded 60 miles per hour. In mild winters, this was manageable. Pantographs scraped ice from the wires as trains passed. The electrical current itself generated enough heat to prevent serious build-up. The system coped. February 1969 was not a mild winter. The storm arrived from the northeast on a Wednesday evening. Temperatures that had been hovering around freezing plummeted to -8 Celsius across the high ground between Penistone and Dunford Bridge. The Pennine Ridge, rising to 1,850 feet at its highest points along the route corridor, acted as a barrier that forced moisture-laden air upward, intensifying snowfall on the exposed eastern slopes. But it was not the cold alone that caused the crisis. It was the combination of cold, wind, and moisture. Wet snow, driven horizontally by gale-force winds gusting to 70 miles per hour, struck the overhead wires and froze on contact. Within hours, the catenary cables that normally measured about an inch in diameter had grown to 3 or 4 inches, sheathed in dense clear ice. Rime formations built up on the insulators. The steel masts themselves became white columns against the darkening sky. The weight was enormous. Each span of wire between masts carried hundreds of extra pounds of ice load. The tensioning weights at anchor points, designed to keep the wire at the correct height for pantograph contact, were overwhelmed. In some locations, the wire sagged so low that pantographs could not make proper contact. In others, the ice coating was so thick that no electrical connection was possible, even when the pantograph reached the wire. The current simply could not flow through an inch of frozen water. The first reports came in just after 8 in the evening. A Class 76 hauling an eastbound freight of 32 loaded coal wagons from Mottram Yard reported intermittent power loss approaching Woodhead Tunnel. The driver described flashes and arcing from the pantograph as it struck ice formations on the wire, bright blue-white sparks visible against the dark moorland. He managed to crawl through the tunnel on degraded power, the confined space of the bore offering some protection from the ice build-up. But once out the eastern portal and into the full force of the storm, he lost traction completely. The locomotive sat dead on the track at Dunford Bridge, its pantograph raised uselessly against a wire encased in ice. 1,500 volts of direct current available in the wire, 0 reaching the motors. The driver radioed control. His message was calm, but its implications were severe. If the ice was this bad at Dunford Bridge, the entire high section of the route was likely impassable for electric traction. Within the next 90 minutes, 3 more electric locomotives reported identical failures across the high section of the route. The overhead line equipment between Crowden and Penistone, roughly 12 miles of exposed catenary, was effectively out of service, not damaged, not broken, simply frozen shut. The control room at Manchester London Road faced an immediate crisis. The Woodhead route carried not just passenger services but heavy coal traffic from the South Yorkshire coalfields to the power stations and industrial works of Lancashire. Approximately 40 freight trains and 20 passenger services used the route daily. Every hour of closure meant trains backing up at Wath Concentration Yard, freight paths missed, passenger services cancelled, and connections broken across the entire trans-Pennine network. And no one could say when the ice would clear. The forecast offered no relief. More snow, more wind, temperatures falling further overnight. The Met Office warned of continuing severe conditions across the Pennines for at least the next 48 hours. The decision came quickly. If the electric locomotives could not run, diesel locomotives would have to take their place. This was not as simple as it sounds. The Woodhead route was electrified precisely because the gradients and traffic density demanded powerful, reliable traction. The climb from either side to the summit involved sustained grades of 1 in 100 and 1 in 200, with heavy trains of coal wagons and 8-coach passenger formations. The Class 76 electrics produced continuous power output that made these gradients manageable. Diesel locomotives available at short notice in the area were not necessarily equal to the task, but there was no alternative. The first diesel substitution ran just before midnight. A Class 45 peak, diverted from its scheduled working, took over an eastbound passenger service at Guide Bridge that would normally have been electric hauled through to Sheffield. The driver, unfamiliar with being routed over Woodhead behind diesel power, found the experience unnerving. The locomotive struggled on the climb to the summit, speed dropping to barely 20 miles per hour on the steepest sections, but it made it through. By Thursday morning, the situation had worsened. Overnight temperatures had dropped further, and the ice on the overhead wires had thickened. Maintenance crews attempted to clear sections of catenary using long poles and by running light engine movements with pantographs raised, hoping the scraping action would break the ice. In some sheltered locations near the tunnel approaches, this worked. On the exposed sections across the moor, it was futile. The ice reformed within minutes of being cleared. British Rail's divisional management issued amended timetables for the entire trans-Pennine corridor. Electric services on the Woodhead route were suspended indefinitely. Every available diesel locomotive in the region was pressed into service. The scene at Sheffield Victoria that Thursday was extraordinary. A station built and equipped for electric operation with overhead wires running the full length of every platform was now hosting nothing but diesel-hauled trains. Class 45s, Class 47s, and even the occasional Class 37 appeared on services that had not seen diesel traction in 15 years. The smell of exhaust hung under the station roof. Platform staff who had grown accustomed to the whine of electric motors and the relatively clean atmosphere of electric traction now worked in a haze of diesel fumes that collected under the Victorian ironwork and glass. Crews accustomed to the clean, quiet acceleration of electric traction found themselves nursing temperamental diesel engines up gradients their locomotives were never designed to tackle regularly. The Class 45s, at 2,500 horsepower, were capable machines on most routes, but the sustained 1 in 100 gradients of the Woodhead Line tested them severely, particularly with heavy 8-coach formations. Engine men reported coolant temperatures running dangerously high on the long climbs. East of the Pennines, the disruption cascaded outward. Services that connected with Woodhead route trains at Sheffield had to be retimed, rerouted or cancelled. The knock-on effects reached Leeds, York, Huddersfield and beyond. This is how Locomotive 5150, a machine with no scheduled business on that particular route, ended up hauling the 2150 York to Aberystwyth mail train as a local service between Leeds and Huddersfield. The mail train, normally a through working, had been broken into sections to cover gaps in the timetable caused by the Woodhead shutdown. It was improvisation on a grand scale. Control room shuffled locomotives and crew diagrams hour by hour. drivers found themselves rostered onto unfamiliar routes. Guards dealt with passengers who could not understand why a railway that had been electric for 15 years was suddenly running on diesel. The irony was bitter and obvious. The Woodhead Electrification had been one of British Rail's proudest achievements, the first mainline electrification of the post-war era. It was supposed to represent the future, reliable, efficient, modern, and here it was, shut down by frozen water, rescued by the very technology it had been built to replace. The diesel locomotives did their job. They were slower, they were louder, they burned more fuel. Some struggled on the gradients, but they ran. In conditions that had completely immobilised the electric fleet, the diesels kept the railway moving, if not to timetable, then at least in something resembling a service. The ice persisted for 3 days, not until Saturday afternoon, when temperatures finally crept above freezing and a slight thaw began, could maintenance crews make meaningful progress clearing the overhead line equipment. Teams worked in shifts along the exposed sections, using insulated poles and de-icing equipment that had been brought in from other regions. Even then, the process was cautious and painstaking. Each section of catenary had to be inspected for damage before power could be restored. Ice loading had stretched some wires beyond their normal tolerance, altering the geometry of the contact wire relative to the pantograph sweep zone. Tensioning weights had to be reset and recalibrated. Insulators that had been subjected to severe arcing during the initial failures needed examination and in some cases replacement. 2 masts between Crowden and Woodhead showed stress fractures from the sustained ice loading and wind pressure, requiring emergency structural repairs before the line could be energised. Full electric service did not resume until Sunday evening, nearly 4 days after the first failure. The February 1969 ice storm was not the first time the Woodhead overhead lines had suffered weather-related failures, and it would not be the last. The route's vulnerability to extreme winter conditions was a known weakness, documented in engineering reports going back to the late 1950s. The exposed moorland sections between Crowden and Penistone were identified repeatedly as problem areas. Various solutions were proposed over the years, including heated catenary wire, chemical de-icing treatments, and modified pantograph designs. Some were tried, none fully solved the problem. The fundamental issue was geographic. The Woodhead route crossed the Pennines at altitude through terrain that generated its own weather. No amount of engineering could change the fact that wet snow driven by Pennine gales would freeze on contact with cold metal wire. The electrification system worked brilliantly in normal conditions, but the Pennines did not always offer normal conditions. This vulnerability became one of several factors in the long, slow decline of the Woodhead route. Through the 1970s, freight traffic was progressively diverted to other trans-Pennine routes. The merry-go-round coal trains that had been the route's bread and butter were rerouted via the Hope Valley Line and the former Midland Railway route through the Peak District. Passenger services, already limited, were further reduced. By the mid-1970s, only a handful of daily passenger workings remained on a route that had once carried express services between 2 of England's greatest industrial cities. The route's unique 1,500-volt direct current system, incompatible with the 25,000-volt alternating current standard being adopted elsewhere on British Rail, made it an expensive orphan. The Class 76 and 77 locomotives could work nowhere else. The overhead line equipment required specialist maintenance teams dedicated solely to the Woodhead route. Investment was hard to justify for a system that served only one route and was periodically shut down by bad weather. On the 18th of July 1981, the last train ran through Woodhead Tunnel. The route closed completely, a decision that remains one of the most debated in British railway history. The overhead wires came down. The Class 76 locomotives, purpose-built machines that had served the route for nearly 30 years, were withdrawn and scrapped. Sheffield Victoria Station, once the eastern gateway to the Woodhead route, closed to passengers and eventually fell into dereliction. The diesel locomotives that had rescued the service in February 1969 outlasted the railway they had saved. There is a lesson in the Woodhead story that extends beyond railway engineering. Technology does not exist in isolation. It exists in an environment, and that environment has the final word. The most advanced system in the world is only as reliable as its weakest interaction with the conditions around it. The Woodhead Electrification was technically brilliant. it transformed a grueling steam-worked mountain railway into a modern, efficient corridor. But it was also built across some of the harshest terrain in England and powered by wires that could not distinguish between rain and the ice that would silence them. The engineers had accounted for cold, they had accounted for wind, they had accounted for snow. What they could not fully account for was the specific combination of moisture and sub-zero temperatures that turned their precision-tensioned catenary into a frozen, useless cable sheathed in glass-hard ice. On that frozen February night, when the overhead lines went dark and the electric locomotives sat powerless in the storm, it was the older, simpler, less elegant technology that kept the railway alive. Diesel engines burning fuel in cylinders, turning wheels through mechanical gearboxes, indifferent to whatever was happening on the wires above. Sometimes the future needs the past to get it through the night. The 2150 mail train reached Huddersfield behind locomotive 5150 at 23 minutes late. The guard noted the delay in his journal. Cause? Weather. The passengers who transferred at Huddersfield for onward connections probably never knew that the locomotive hauling them was an emergency substitution on a railway that had, for 3 extraordinary days, forgotten how to be electric. The Pennines did not care. They never do.